So looking at the top of worksheet 3, let's draw a little triangle, ABC. Across from A is A, across from B is B, across from C is C. And the one new thing today is the area of that triangle. Do you remember the formula for the area of a triangle? Because if you remember a formula, it will help tie into this form. 1/2 base times height is the formula you're probably used to. And so that's not wrong, but you need a height to use that formula. If instead you don't have a height, you can do 1/2 A times B times sine of angle C. So that's a new area formula, area of a triangle. It's very much related to 1/2 base times height. A and B, it doesn't have to be A and B, it's really any two sides. And angle C is the included angle. Included angle. That just means the angle between the two sides that you have. So number 1, find the area of the triangle on the right. Well, I've got two sides and an included angle. So 1/2 AB sine of angle C. So 14 and 16 are the two sides. And the included angle is 33. And again, calculator heavy today. 0.5 times 14 times 16 times sine 33, although I better check degree versus radian, especially since it's first period and I don't know what's happened to this calculator since last time we spoke. So 1/2 14 16 sine of 33. Multiple choice makes it nice because, yeah, there it is. Thank you. All right. Now you really have seen everything for the week. You're welcome. All right. Can you not sit right next to her since you got the same test? Let's look at, I picked some out to look at. These are all not old, but problems from yesterday, formula from yesterday. So let's look at number 3. To find the distance across a small lake, a surveyor has taken the measurements shown. Find the distance in feet across the lake. So there's what we're looking for, that distance. Can you tell yet if this is a law of sines or a law of cosines problem? 1 yes. Why do you say law of cosines? I agree. Okay, yeah, there's not an angle side pair, so it's got to be law of cosines. Another way to say it is this is an SAS problem, so it's got to be law of cosines. So with that hint, why don't you do number 3? Right, d squared equals ... I'll hit pause and you find the distance across the lake. So there's my setup. So which one did you get? A, B, C, or D? B. Good. Question on that? Like, I don't want to go too fast, but I also don't want to go too slow. Jake?
How do you know to use cosine?
Okay. Good question. How do you know to use cosines? First, look for law of sines. If there's a pair across from each other, then you can use law of sines. If there's not a pair, like an angle side pair that you know, then you have to use cosines.
Okay.
So if there's an angle side pair you can use sines. And if there's not, you got to use cosines. Let's look at number 5. To determine how far a boat is from shore, 2 radar stations, 500 feet apart. Determine the angles out to a boat. Find the distance in feet of the boat from station A. So we're looking for that distance. I guess we could call that B because it's across from angle B. What do we think? Is this law of sines or law of cosines? Why sines? I don't see an angle side pair. Right, so this one's a little bit tricky. Right now there's not an angle side pair, but let's see, 70 plus 60 is 130. So if this is 50, that makes 180. And now we've got an angle side pair to use for law of sines. So pair that up with this information. I'll hit pause. You see if you can answer number 5. So you set that up with the known pair of angle side, and you set that equal to the unknown pair of angle side. Do a little cross multiplying, and you guys are showing various amounts of work, which is fine. Not many people showed more than this, because you knew you could take that last step in the calculator and just divide by sine of 50, and you end up with 565, letter C. Questions on that one? All right, let's turn to number 7. Again, I'm just picked some ones that I thought were representative of the others. 7 gets a little more complicated because we got an angled thing on top of an angled roof. So the roof of a house is at a 20-degree angle. An 8-foot solar panel is to be mounted on the roof and should be angled 38 degrees relative to the horizontal for optimal results. How long in feet does the vertical support holding up the back of the panel need to be? So this thing right here is the distance we're looking for. Well, I'm going to try to just pull out that triangle. So is there anything we can figure out in that triangle? Anything else we know? I drew it really skinny, but I think we can figure out that angle. Okay, hold on a second. Yeah, I heard 90 minus 38. 90 minus 38 would be this angle. So what's that? 52. So that angle would be 52. But this angle down here, do we know what that angle is going to be? Let's see. It would help if we could sort of see this. The bottom part of it is geometry stuff. Is 20. So the top part of it is 18. Which means now we can figure out what this angle is. So 180 minus 52 minus 18. So that angle is 110. Okay with all those angles? No. Okay, back up a second then. Let's look at this triangle. Looking at that triangle, that's a right triangle. And so that's how we knew that this top angle was 90 minus 38, because everything's got to add to 180. So 180 minus 90 minus 38. So we get 52 for the top angle. And then this triangle, this is really the triangle we want to work with. Like we knew this full angle is 38 and this angle is 20. So the top part of the angle has got to be 18. This is one of those where there's no magic equation. You just have to look and think and draw and figure out the different pieces. Now that we have all the angles of the orange triangle, is this a law of sines or a law of cosines problem? Sines. Which pair do you know?
110 and 8.
Yeah, the 110 and the 8. So sine of 110 over 8 equals, well, we want side D. What angle is across from D? There's like 5 different angles labeled in this picture. 18 is across from D, so sine of 18 over D. Well, it should be easy from there, but the setup for that problem was the tricky part. Some of you aren't going to show, you're going to show that much work. I do need to see that much work. I do need to see your setup so I know which, that you know it's law of sines and you got it set up right. If you jump to the calculator from there, that's fine because you know that it's D sine 110 equals 8 sine 18 and then divide both sides. I'm not worried about that, but I do want to see the setup. Why don't you try number 10? That's another triangle on a triangle with lots of different angles thrown in there. So you see if you can get number 10. So it's law of cosines, call it angle A, and then setting it up, angle A needs to be across from 175 in the picture and across from 175 in the equation. And then I'll use the other two sides, 64 squared plus 127 squared minus 2 times 64 times 127. You didn't space that out very well. Okay, so now it's an algebra problem, right? Like that's the pre-cal part. Now the algebra, and I'm trying to get cosine of angle A by itself. So let's subtract over the 64 squared and the 127 squared. And by the way, I'm not finding any values for these yet. I'm going to do all the moving around first and then go to the calculator. So subtract over the 64 squared and the 127 squared. And then, Toby, do you remember what to do next?
Divide by 2 times 8.
Yeah, I'll divide by all of that stuff. Negative 2, 64, 127. And then now it's a calculator problem. And preferably a calculator with a fraction bar so I'm not worried about parentheses. Let's see, 175 squared minus 64 squared minus 127 squared. All of that over negative 2, 64, and 127. Weird fraction. That's not my answer, though. How do I get my answer? Inverse cosine that. So the cosine equals that thing. I want the inverse cosine of that. I need to undo the cosine. And then hopefully 129 is one of my answer choices. Uh-oh. Find the angle the tower makes with the hill. Well, I'm glad we picked this one to do. The tower with the hill. Does it want the small angle over here? This angle? I don't think that's what... The tower with the hill's got to be the one I drew. Right? Maybe you could argue the other side, but that would just be 180 minus the answer we got, which is also not one of those. So, I'm guessing, like you said, I'm guessing these answer choices are this angle, but that is not the angle the tower makes with the hill. So I'm going to stick with my guns and say that's 129.774. I'm glad I picked that one to look at. The angle the tower makes with the hill. I don't know how else to interpret that. But yeah, just looking at it, those look like that angle, but that's not what it asked for.
It's asking for the one I got the answers.
So one of these is this angle?
Yeah.
I believe that. But that's not... They would need to ask that some other way. Like, what's the angle the hill makes with the horizontal? Or how steep is the hill? Something like that. So, I don't like number 10, but it got us practice on law of cosines. Let's do 11, because there's some geometry in there. Geometry experts here. A pilot is flying over a straight highway. He determined the angle of depression to 2 mileposts, 6.6 kilometers apart. Oh, so that's 6.6 kilometers from A to B. One of them's 37 degrees. One of them's 44. Find the distance the plane is from point A. So we want that distance. Okay. Well, here's the triangle I think we should be looking at. This is a little weird. Like, I don't know any angles in that triangle. I mean, I know some of the angles, but not specifically in the triangle. So what can I do to find an angle in the triangle?
180 minus 37 minus whatever.
Okay, so 180 minus those two would give me this guy. 180 minus 37 minus 44. It's 99. So I'm thinking law of sines, right? Because I've got 99 and 6.6 across from each other, so that's probably law of sines problem. But I need another angle, preferably angle B, because that's across from the side I'd like.
Oh, there's a 90-degree angle.
Like that?
On
Oh, like this? Okay. You could get there that way. That would be fine. I would say, this is geometry here. When you have two parallel lines and an angle or a line crossing them like that. Yeah, and I don't really care that you remember what it's called. I'll remind you what it's called. Anybody remember what this line is called? Starts with a T. I'll be super impressed if you remember what that thing is called.
transverse.
Close, transversal. So this line that I'm wiggling here, that's a transversal. But more importantly, so we can kind of ignore this other stuff. What angle can we know? Let's see, if that's 44. Then that one's 44. Yeah, it's like, how do you explain that one? They did have specific names. Alternate interior angles. Again, it doesn't matter that you remember what they're named. It does matter that you remember sort of how this thing works. 37 and 37 would work as well. So now we're set up for a law of science problem. See if you can finish out number 11. Cross multiply and divide. 4.642. So answer choice A. But think with most of these, the problem is not the law of sines or cosines, it's figuring out the missing angles. Let's do one more together, and that's number 13. This one does not have a picture with it, so we'll have to be a little extra careful. To estimate the height of a building, two students find the angle of elevation from a point at ground level down the street from the building to the top of the building to be 39 degrees. Okay, that's a lot of words. So here's our ground level point. Angle of elevation means if you look up, what angle do you look up through? So if you're looking up to the top of the building, that 39 degrees is your angle of elevation. Okay, so the two students are standing over here. They look up to the top of the building, and that angle is 39. From a point that is 300 feet closer to the building, so 300 feet closer to the building, the angle of elevation at ground level, so they're not climbed uphill or anything, to the top of the building is 50. So now they moved closer, and that angle is 50. If we assume the street is level and the building is vertical, right, so everything's, right angles here, nothing's slanted, estimate the height of the building. So if I only look at this triangle, I don't think I have enough information. Thank you. I don't have enough information if I only look at, there's no side links in there. So that's the triangle I like, but there's nothing there, so I don't know if that helps me a whole lot. If I look at the big triangle, I don't have a side length either because I've got 300, but that didn't. I think I have to start with. I think I've got to start with this triangle, and this may be a multi-step deal here because I know a length in that triangle, so I pretty much have to start with that triangle. And if I could get this length, I'm just going to call that A. If I could get that length from the blue triangle, then I could transfer that over and use it in the green triangle. And then I could find H. So I think I've got two problems here. I'm going to use the blue triangle first, hopefully find A, and then I can use that in my green triangle to find H. Alright, so what else do I need to find? I'm thinking and hoping law of sines here because 39 and A are across from each other.
130 angle.
Okay, so yeah, this is 130. Because 130 and 50 got to add to 180. And then this top angle I can find, 180 minus the other two. It's 11. Okay, now I think I'm good. What's the angle side pair that I know? 11 and 300. Yeah, it's almost tricky when it's an obtuse triangle because maybe it's a little harder to see what's across from what. So sine of 11 over 300 equals, I'd really like to find side A. And what angle's across from side A? 39. So then I'll know A, and then I can use that in the green triangle. So here's my blue triangle information. (300 sine 39 divided by sine 11. $989.451. All my answer choices, like none of them are super close, so 3 decimals should be more than enough. Right? If all my answer choices were really close to each other, I'd want to be really careful about decimals, but they're far enough apart that 3 decimals should be fine. Okay, so now I know side A. So this is a right triangle, so SOHCAHTOA you could use, but you could also still use law of sines. So I now know a pair. So even though it's sine of 90, it still works. So sine of 90 over A equals sine 50 over H. And I'm almost there. And speaking of rounding, I don't have to round because I can leave that 989 in my calculator and do times sine of 50 divided by sine of 90. 758. Is that an answer choice? Yes, it is. So that was a tricky one because the 2 triangles in there. And there may have been even other ways to work that one. But that's the way I saw to work it. Yeah. All right, so the rest of the worksheet 3 is yours to work on. If you get motivated and start looking ahead, worksheet 4, that's tomorrow's assignment. But I'll tell you now, just in case, it's going to be only the odds on worksheet 4, tomorrow's assignment. So worksheet 3 is all of them. It's lots of good practice. Worksheet 4 is kind of long, so the odds will be plenty to work on. And then again, we'll have a test on Friday. So here's the summary here. Monday was worksheet 1 and 2 odds. Tuesday is worksheet 3 all. Wednesday will be worksheet 4 odds. And then Friday we'll test. Again, we should be more than ready come Friday.